It's time to talk about IV characteristics. The first and most important thing to just mention here is what are I and V, okay? So I is the current, okay? The electrical current, which would usually be measured in amps, and V is the potential difference. Okay, so potential difference is going to be measured in volts. You often hear people talking about voltage. Potential difference and voltage are the same thing. So IV characteristics, we've got some explanation here and we've got a method. So the first thing we're going to do, and this may seem a little bit backwards, but we're going to talk about the results first. So what is an IV characteristic? A current voltage, current potential difference characteristic. Well, it's a graph for a given component. So you're going to have the potential difference and the current, and we're going to actually draw three of these because we're going to do this for three different components. So we've got current potential difference, and you need to be able to recognize these graphs. So let's put a different color here. The first one we're going to do is we're going to talk about a resistor at a constant temperature, and this is going to be a straight line through the origin. So this is a resistor. The symbol for a resistor we know is a little rectangle like this, okay, at a constant temperature. The next one we're going to talk about is a lamp or a filament lamp, a light bulb, different things we might call it. We've got a filament lamp, and the graph is going to be a bit curved. It's going to look something like this. So this is a lamp, which we hopefully know the symbol looks like that. And the last one is an LED or a diode. It's a bit interesting because nothing really happens on the left hand side, and then it's going to start to shoot up on the right hand side here. I'm going to call this an LED. LED stands for light emitting diode. It could be a normal diode. A normal diode doesn't give off light. An LED is a diode that does give off light. And we're going to talk about that. The symbol for a normal diode would just be this symbol here, and a light emitting diode has a couple of arrows shooting off that represent light. So these are our IV characteristics. They tell you what happens to the current when you change the potential difference, you change the voltage. So as we can see on the resistor here, as you increase the voltage, you increase the current. And it's actually directly proportional. It's a straight line through the origin. With the lamp, as you increase the voltage, you increase the current, but it doesn't increase at a constant rate. We're going to talk about why. And with an LED, as you increase the voltage, you increase the current, but only if you are applying a positive voltage, okay? A voltage in the positive direction. If you apply a voltage in the negative direction, it will not let any current go through. And that's what a diode does, okay? So a diode only allows current to go through in one direction. It will have an incredibly high resistance in the reverse direction. Therefore, you will not get any current in the reverse direction. The resistor, well, this is obeys something called Ohm's law, okay? So this obeys Ohm's law, which says that the current is directly proportional to the potential difference or voltage for a metal wire at a constant temperature, okay? So the current is directly proportional to the voltage. So if you add a certain amount of voltage, you'll get a certain increase in current. If you add the same amount of voltage again, you're going to get the same increase in current. Now the lamp is a bit different. This is the one you most often get asked to explain. And the reason here is that the lamp does not stay at a constant temperature. The whole reason a lamp works is that you put the current through, the wire gets hot, it glows, it gives off light. So what we say is as the potential difference increases, now I'm going to do this in shorthand with little arrows, as potential difference increases, the current increases, okay? We can see that happening. As the current increases, the wire gets hot. So as the current increases, the temperature increases. And when the temperature of a metal wire increases, the particles inside start to vibrate more vigorously at a higher speed, and it's more difficult for the electrons to get through. Those electrons are trying to get through this wire, and they're struggling because you've got all these particles constantly vibrating backwards and forwards. So at a high temperature, it's more difficult for the electrons to get through, and therefore resistance increases. And that means that whilst a small increase in voltage at the start will give you quite a big increase in current, a bit later on when the resistance is higher, that same increase in voltage is going to give you a smaller increase in current because the resistance is higher. Now, that explanation is high level understanding, but the most important thing here is that we can recognize these graphs for the resistor, the lamp, and the LED. So the next slide, we're going to talk about the method. So how do we actually know this? What would we do in an experiment to get these results? So that we need to think we're going to have to measure the voltage, the potential difference, and we're going to have to measure the current, and then we're going to have to change it so we can get another reading. Because if we only measured the potential difference and current once, you might get a reading like this, that cross on your graph. But you need to change those values so we can get another reading, and then change them again so we can get another reading, etc. Okay? And then you'll notice as well, we need the backwards reading, so we're going to have to do something to get the reverse readings as well. And we're going to I'm going to show you how we do all that. It's reasonably simple. So here's the method. Well, obviously in any circuit you're going to need yourself a power supply. Okay, so we'll take a cell. It could be a battery or power pack or something, but I'm going to call it a cell just to keep it nice and straightforward. You're going to need to measure the current in the circuit, and to measure current we need an ammeter, and we'll notice that this ammeter is going to be placed in series. That's in the same loop. An ammeter measures the current. It measures how many charges go past every second. So it would be like standing on a walkway or by the side of a road, okay, and counting how many cars go past you every second. You want to be along the side so you can see them go past, okay? So the ammeter has to sit in the loop to count how many charges go through it every single second. Then we're going to have our component. Now I'm going to draw this for the, we'll do the light bulb, okay? So I'm going to draw this for the light bulb, but where I place this light bulb, I could place the light bulb or the resistor or the LED. It doesn't really matter. So I'm going to place the light bulb in here, okay? Now we need to measure the potential difference. Now potential difference, we use a voltmeter, and you'll see here that I use the voltmeter in parallel. Now think about that term, potential difference. This voltmeter has to say, what is the potential here? What is the potential here? Now I'm going to tell you the difference. So to remember where the voltmeter goes, we've got that word difference. If you want to know the difference between two things, you've got to look at it in one place, you've got to look at it in another place, and then you can tell the difference. So that's why the voltmeter is connected in parallel. Okay? And then the last thing that we're going to put into this circuit is a variable resistor. And we need this so we can change the values and get those multiple readings. Okay? So we've got, to summarize here, we've got our ammeter in series. So we've got an ammeter in series to measure current. I will point a key thing here. Lots of people think an ammeter measures amps. Okay, it measures the current in amps. If you get asked what quantity an ammeter measures, it measures the current. We don't say it measures amps. So an ammeter in series to measure the current. That's going to be part of our method. A voltmeter in parallel to measure potential difference. If you said to measure voltage, you'd probably be okay, but the best term is potential difference. And then we've got our a variable resistor to change V and I and get the next set of readings. And this is almost the entire method right here on this page, okay? Ammeter in series to measure current, voltmeter in parallel to measure potential difference, and the variable resistor to change those values. The only thing we've not covered is how to get those negative values. So if I look at this, we've talked here about how to get these positive values, but we haven't said about how to get these negative values. So all we need to do is we need to then just say, at the very end, we're going to say that finally we need to swap the terminals Okay, we need to swap the terminals on the power supply, which in this case is a cell, and then repeat. So that would be literally taking this wire here and connecting it onto this side, and taking this wire here and connecting it onto this side. Okay, and that's going to give us our negative results. That's it for your method. That's all you need to know. So it's thinking about where you place your ammeter and why, where you place your voltmeter and why, and how we change those values. That is your method for IV characteristics. Okay. The final thing I'm just going to mention is a little calculation that they could ask you to use in relation, and that's V equals IR. Potential difference is current times resistance. If you had a graph, and I'm going to draw a very rough one here. Okay. Let's say you had a resistor. Or no, let's make it more interesting. Say we had a light bulb, a lamp, okay, and you've got some numbers along here. It would be much more precise than this on the exam. Let's say this was the potential difference 1, 2, 3, 4, 5, 6 volts, and let's say this was current, and this was 0.2, 0.4, 0.6, 0.8, 1.0, 1.2 amps. Now a question could ask you to calculate the resistance. And the resistance, if we use this equation, V equals IR, okay, put it into an equation, I times R are going to go on the bottom, V here. So resistance is V divided by I, the potential difference divided by the current. And it would say at a certain voltage. So the question might say resistance at 4 volts, in which case you're going to get your sharp pencil out, you're going to get your ruler out, and I can't really do this on the tablet, but with a ruler you are going to draw yourself a line down to 4 volts, okay, at whatever value it says. With a ruler you are going to draw a line across to here, and in this instance we're going to say I've got 4 volts, and again it would be much more precise on your exam, but that's about 0.9 amps divided by 0.9, and that is going to give you your resistance. In this case, 4 divided by 0.9 is going to be 4, it's actually 4.4 recurring, so 4.4, and the unit for resistance is ohms. Okay, so just to clarify, just to remind ourselves, the main thing here is this method about knowing where the ammeter goes, where the voltmeter goes, and why, and being able to identify these 3 different graphs for IV characteristics.